So in the previous two videos, we used this schematic to determine which intermolecular force or forces are present in a molecule. And the molecules that we looked at were sort of small molecules, molecules that had one central atom with, two or three or four things attached. What if I was to give you a larger molecule, something like I have down here? This is butane. What if I was to give you a molecule like this and I was to ask you what type of intermolecular force or forces were present? You could still answer that question based upon the concepts we've talked about in this chapter and this flowchart. To determine, you would say, is the molecule polar? And so looking at this molecule, you could look at the molecule, look at your electronegativity table, and see that hydrogen and carbon, when you take the delta En of those, you get something that is non-polar. The change in electronegativity between carbon and hydrogen is 0.4. For each carbon-carbon bond, the delta En is 0. So molecules that just have carbon and hydrogen, also called hydrocarbons, they are generally non-polar. So this is a non-polar molecule. So that would lead us here to the no section. It is not ionic because this is all nonmetals. So in this molecule of butane, the only force that would be present would be dispersion forces. What if I was to give you a molecule like this? Now, hopefully this should not panic you. I'm not going to ask you to draw something like this, but you should be able to look at a molecule like this. This is actually glucose in its cyclical form. You should be able to look at this and, using the concepts we've talked about, say something about the intermolecular forces present. So to determine if the molecule is polar or not, you're not going to be able to use a Lewis dot structure to determine that, but you should be able to look at this molecule of glucose and say, oh, I see a carbon-oxygen bond, and I see an OH attachment. Oh, and I know that carbon and oxygen, carbon has an electronegativity from your electronegativity table that you'll be able to use for quizzes and exams. That has a value of 2.5. Oxygen is 3.5. So I've got a polar region right here. I have a polar region due to the OH bond. So this is definitely a polar molecule. Does it have hydrogen directly bonded to a nitrogen, oxygen, or fluorine? Yep, it sure does. I have an example of hydrogen bonding from the OH, either that one or this one. I have an example of hydrogen bonding. Whoops, sorry. I have an example of hydrogen bonding. I also have an example of a dipole-dipole force due to this CO bond. So in this molecule of glucose, I have obviously dispersion forces, because that's common to all molecules, but I have dipole-dipole due to this CO bond, and I also have hydrogen bonding due to the OH bond. Okay. So given a structure like this, you should be able to use that kind of thought process to determine the types of intermolecular attractions that are present. And that is the end of this section on intermolecular forces.